This is Geometry, Chapter 6, Lesson 5 on page 236. In this lesson, everything in this lesson I've already covered. Everything. Because I covered in earlier lessons when you actually need it. All right? So the first part of this lesson, well, the whole lesson is on angles of a triangle. So let's talk about all the angles and the relations of every angle in a triangle. One, 2, and 3. What do you know about angles 1, 2, and 3? Yes?
They add to equal 180.
The sum of, they're called interior, the interior angles of a triangle is always 180. Yes?
1 and 3 have to be greater than 2. The sum of them.
Okay. You're close, but I'd have to put a 4. Because really it's just the sum of them have to be 180. Okay, yes, Landry.
Is this an equilateral triangle?
No, it's just any triangle. That's a 12, not a 2. Okay. So now what are the angles outside called? There's actually a couple of names. Yes, Selby?
Well, there's exterior angles and then,
Okay, which ones are exterior?
well, the exterior angles are the ones that form they're supplementary to the ones inside. So like for angle 1 at the top, 10 and 12 are both exterior angles.
Correct. So for angle 1, 10 and 11 are exterior because they form a linear pair and are supplementary to the 1. All right? You see that? See that, Ari? All right, which ones are exterior, Ari, at this vertex?
9 and 7.
9 and 7.
Sorry, I just got confused for a second because you said 11, but I think you meant 12.
I did mean 12. I didn't, if I said I meant 10 and 12 are exterior and form a linear pair. Thank you for correcting that. All right, what about at 2, Chris? Which ones are exterior?
5, 4.
5 and 4, that's right. So what are 6, 8, and 11? Ethan, what are 6, 8, and 11?
Well, they're removed too. I can know that they are vertical angles with, like angle 1 and 11, and then angle 2 and 6 and 3 and 8.
That's right. They're vertical to the interior angles, right? They're vertical to the interior angles. Okay, so what relations can we say? All the relations between 4, 1, and 3. What are all those relations? David.
They add up to 180. Could you restate the question?
Yes.
I can't.
Because there could be an instance maybe when their sum is 180. But it would not always be the case. All right, so one relation that you know of that's possible between 1, 3, and 4. What, Landry?
4 has to be greater than 1 and 7.
That's right. So angle 4 would be greater than angle 3, and angle 4 would be greater than angle 1 because why? Do you remember the statement? Because, why is this true? You have it, Ari?
I know you're looking for a specific statement.
Words.
I don't know what that is.
Okay, use your words.
Okay. Since angle 4 is greater than
is equal to angle 12 and angle 12
Well,
and
4 is not necessarily equal to 12. Why would 4 be greater than 1 and 4 be greater than 3, Luke? Okay, so say all the words. Yes, an exterior angle is greater than either remote interior angle. David,
Would 4 be greater than 2, or can we not know that?
you cannot know that. Does it look like it visually?
Well, yeah, but
Okay, but you cannot know that. Do not write that on the test. If you think 4 visually looks greater than 2, that would be the wrong answer. There is no theorem that says that. The only thing we can know about 2 and 4 is that they're a linear pair and their sum is 180. But we can say that 4 is greater than 1 and that 4 is greater than 3 because an exterior angle is greater than either remote interior angle. Okay, what other yes, Selby?
Would 1 and 3 be equal to 4 together, or is that not?
Yes, that is true. Angle 1 plus angle 3 is going to equal the value of angle 4. Why? Yes, Selby?
I can't remember the exact words, but it's something like the remote angles equal like the opposite.
Let's use this word. The what?
Wait, what are you pointing to?
This sign. The sum of the
Remote
interior angles
equals the opposite exterior angles.
equals an exterior angle. By definition, these are remote to this exterior. Yes.
And is 1 plus 3 also equal to like 9 and 10 that or not?
No. So what does 9 equal the sum of? 9 equals the sum of 1 and 2. Do you see that, Isabella? Okay, 9 is exterior, right? The remote interiors are the ones inside the triangle that it does not form a linear pair with. So angle 9 is greater than 1 and 9 is greater than 2. But also, angle 9 equals the sum of angle 1 plus angle 2. Yes?
So is like whole greater than part or something? Could you say that or not?
Not whole greater than part. What does whole greater than part say? Okay? Let me draw something else. What's the whole angle?
COA.
COA. What parts make up the whole angle?
COB plus BOA.
Right. So the whole angle COA is greater than COB. I could say that. That's whole greater than part. Or I could say COA is greater than BOA. You could also do it with a line. AC is greater than AB and AC is greater than BC. Because the whole AC is greater than any part that makes it up. That was a good question to ask. All right, do y'all understand all these angles? All right, let's read through the theorems on page 237. The sum of the angles of a triangle is 180. Got it? If two angles, this is corollary 1, if two angles of one triangle are equal to two angles of another, then what do we know about the third angles? How does that make sense? How does that make sense? If I have two triangles, and let's let's say that's 60 degrees, that's 60 degrees, that's 35 degrees, that's 35 degrees. What can we say about B and angle E? Do they have to be equal? Why?
Angle, side, angle.
How do we know what sides are equal? Did I say anything about sides?
Well, if you know two angles, then the opposite one has to be.
Okay, what is that one? Two angles are equal. The sides opposite them are equal. Is that in two different triangles? No, it's in one triangle. If two angles of one triangle are equal, then the sides opposite them are equal. Well, what does the sum of the angles in a triangle have to be? Okay, so 60 plus 35 plus B has to equal 180, right? And the same in this one. 60 degrees plus 35 degrees plus angle E has to equal 180 degrees. Yes?
B and E would both be 85 degrees.
Okay, we're getting there. We're like walking through the proof to prove it. Why can I write these statements? Not given?
The angles from theorem. The sum of the angles of triangles.
The sum of the angles of a triangle equal 180 degrees. That's why I can write that statement. Okay? Why can I write this statement? How can I go from here to here? Selby?
Subtraction.
It's subtraction. Did you follow that? What did I subtract from both sides? What?
95.
Yes.
Yeah, I was confused.
I subtracted wrong in my mentally. I did mental subtraction wrong.
I didn't even notice.
Thank you for not, well, I'm glad somebody noticed. Okay? Now why can I write what would that be? David? Chris? Substitution. Right? You could go either way. So for E, well, for 85, in this equation, I substitute E. It's substitution. All right, so that's how we get the corollary, is through this logic. All right, look at corollary 2. The acute angles of a right triangle are complementary. What does that mean? The acute angles of a right triangle are complementary.
They add to equal 90 degrees because one side is 90 degrees, so they have to equal 90 degrees.
Correct. All right, so the acute angles of a right triangle. That means this angle and that angle. A plus B are always acute. They can't be obtuse because it's a right triangle, right? The sum of A plus B has to be 90 degrees. That's what corollary 2 says. The acute angles, because they're acute, of a right triangle are complementary. Each angle of an equilateral triangle is 60 degrees. How do we know that? Each angle of an equilateral triangle is 60 degrees. How do we know that? Landry?
Because all the sides, or all the angles have to add up to 180 degrees.
Right.
And so when you divide that by 3,
And because all the sides are equal, you divide that by 3,
which is
because all the opposite sides of, all the opposite angles of those equal sides have to be equal, right? So it's all 60. You just take the 180 and divide it by 3. All right, look at the last theorem. I taught it earlier. An exterior angle of a triangle is equal to the sum of the remote interior angles. Yes?
Why do they have like remote interior angles? Why can't it be like interior
okay? It has to be remote,
What does that like mean? Remote?
okay? I'm gonna explain it. 3 is not remote to 4. It's a linear pair. Remember I told y'all,
Oh, they
it's
don't
like,
form anything together? Like there's nothing formed, like a vertical angle or anything?
the only remote ones are the ones far away. The word remote means like there's a distance, right? It's far away. All right, so we have 3 interior angles. So not all 3 interior angles are remote or far away from 4. The only angles that are remote to 4 are the ones far away, 1 and 2. It's like me watching football on a Sunday, having 2 TVs with the remotes, right? You remember that illustration? Okay.